Hi everyone. In last sessions we have discussed about position isomerism. Now next one is functional isomerism. Third one is functional isomerism. It is one of the types of structural isomerism. What is functional isomerism? So definition is almost the same, similar to position, similar to chain isomerism, or otherwise structural isomerism. Compounds with same molecular formula and differ in their structures means structural isomerism. Structures may be position, change in position, or change in chain lengths. Now it is functional group. So here I am writing compounds, compounds with identical compounds with identical molecular formula. Compounds with identical molecular formula and differ in their functional groups. Differ in their functional groups are called functional isomers, and the phenomena involved in this are called functional isomerism. Here examples are very important. Combinations of examples means two functional groups may be present in same molecular formula. Here first example here is alcohols, and ethers. Alcohols and ethers are functional isomers. See here, if you take two carbons, here minimum number of carbons required are two. One carbon containing alcohol, otherwise one carbon containing ether is not possible. For writing ether, minimum two carbons are required. But for writing alcohol, one carbon is also enough. But one carbon containing alcohol will not show functional isomerism with ether. So minimum two carbons are required. So here I am writing CH3, CH2, OH. So what is the molecular formula here? MF. Molecular formula of this compound is C2H3H21 means H6O. This is molecular formula. For this molecular formula, I written one alcohol here. What is the name of this alcohol? Two carbons are there. So root word is eth. And the suffix for OH functional group is ol. Ethane plus ol. Ethane plus ol means ethanol. Ol is the functional name. Otherwise, the common name, it is ethyl alcohol. It is ethyl alcohol. For the same, we can write is ether. What is the functional group in ether? It is internal functional group containing compound. This is the ether functional group. So this side one alkyl group, this side one alkyl group we have to write. Here two carbons are there in alcohol. These two carbons I am dividing, and one carbon I am writing here, one carbon I am writing here. So here this is a terminal carbon. It requires three hydrogens. It is also terminal, so it is also requiring three hydrogens. Total how many? Two carbons, six hydrogens, and oxygen. But this is the methoxymethane, IUPAC name. Otherwise, we can say dimethyl ether. Common name is dimethyl ether. IUPAC name is methoxymethane. One side, methyl group is there. No? This methyl along with oxygen, we can say methoxy. And this is one carbon containing alkane. That is methane. So for both the molecular formula is same, but there is a different functional groups. Because of OH functional group, its properties different from this one. Because of ethereal functional group, properties of this compound is different from this. So compounds with same molecular formula and differ in their properties due to two different functional groups is nothing but functional isomerism. This is one example. So one more example is here is we can write means many like these compounds we can take. Is ether. This is ether and alcohol. Here for the same I am writing one more CH3 CH2 CH2OH. Double one compound I am writing here. For this molecular formula, MF is 1, 2, 3, C3, 3 plus 2, 5, 5 plus 2, 7 plus 1, H8 and 1 oxygen. This is the molecular formula. This is the molecular formula. For the same, I am writing one more compound here, that is the CH3, CH, here I am writing OH, then CH3. This is also alcohol. This is also alcohol. This is 1 ol, this is 2 ol. This is N-propyl alcohol, this is isopropyl alcohol, common names. N-propanol, it is 2-propanol, propane 2-ol we can say. One more compound what I am writing here is third one, like CH3, O, CH2, CH3. So this is ethyl methyl ether. Ethyl methyl ether. For this also same molecular formula. What is the molecular formula? C3H8O. See here 1, 2, 3 carbons, 3 plus 2, 5 plus 3, 8 hydrogens and 1 oxygen. Total C3H8O. Here it is, we can say methoxy ethane. Always while writing IUPAC name for ethers, less number of carbons containing alkyl group always with oxygen, and it should be pronounced as alkoxy. And other side with more number of carbons containing alkyl group is there, no, that should be pronounced as alkane. So alkoxy, alkane. So that here this side less number of carbons containing alkyl group, that is 1 carbon. So methoxy written along with oxygen, and 2 carbons containing alkane is ethane. Otherwise simply ethyl methyl ether. Ethyl methyl ether. These are the different compounds with respect to C3H8O. And like this they give in the question. 3 compounds, 3 different compounds they give. Then they ask what is the relation? Relation between 1 and 2. Otherwise relation between 1 and 3. Relation between 2 and 3. Like that questions they may ask. What is the relation between 1 and 2? Here I am writing 1 first compound and second compound. 1 and 2 are 1 and 2 are position isomers. 1 and 2 are position isomers. Otherwise we can say resiomers. 1 and 2 are position isomers or resiomers. Then 1 and 3. 1 and 3. These two are functional isomers. These two are functional isomers. These two are functional isomers. Then 2 and 3. 2 and 3 also functional isomers. 2 and 3 also functional isomers. 1 and 2 is position isomerism. 1 and 3 functional isomers. 2 and 3 also functional isomers. Like these questions they may ask. So like these combinations first you have to write. After writing the different combinations, you have to check what is the relation between different compounds. So like these questions they may ask. This is one example. Alcohols and ethers. Alcohols and ethers. In this way you have to remember. Then next second example I am giving here. Carboxylic acids. Carboxylic acids and esters. This is another combination. Alcohols and ethers are functional isomers. Similarly, carboxylic acids and esters also functional isomers. See here, I am giving one example. Here also, 1 carbon containing carboxylic acid will not show. Functional isomerism with ester. See here, I am writing like this H C double bond OH. This is the first member of carboxylic acid. We can say it is 1 carbon means methane, and Oic acid. It is methanoic acid. Otherwise, formic acid, it is also called as formic acid. Common name is formic acid based on their source. For this, it is not possible to write ester. So ester functional group is like this. We can write C double bond O. Here O. Here this side one R group, this side one R group is present. Alkyl groups is present either side of this group. We can say it is ester. But to write two alkyl groups that side and this side, we need minimum two carbons. So one carbon containing carboxylic acid will not show isomerism, functional isomerism. See, because at present I am extending one carbon here, CH3 I am taking. Two carbons containing carboxylic acid. What is the function? What is the molecular formula here? 1, 2. Two carbons. Here I am writing C2, H4, H4 and two oxygens O2. This is the molecular formula. C2, H4, O2 is molecular formula. See here what I am writing, one hydrogen. So one side hydrogen also we can write, but the other side we can write alkyl group. This side I am writing CH3. This CH3 I written this side, this hydrogen which is present beside oxygen I written this side. So these two are functional isomers. The name of this compound is ethane and oic acid, ethanoic acid. This is ethanoic acid. This is ethanoic acid. And here this is ester. Ester means first you have to write this part while writing IUPAC name. Means what is the alkyl group, that alkyl group first you have to mention here. Then after this part means here how many carbons are present with respect to that O8 we can write. Because ester's functional name is O8. So this part is the O8 part, this is alkyl part. So this is the methyl, one carbon containing carboxylic acid is methanoic acid. Methanoic acid anion name is methanoate. So methyl methanoate we can write one carbon. Methyl methanoate. Methyl methanoate. This is ethanoic acid and that is the methyl methanoate. Both are having same molecular formula. Once you observe, here also two carbons and hydrogens are 4, 3 plus 1, 4 and 2 oxygens. So carboxylic acid and ester both are having same molecular formula, but two different functional groups are present. Because of difference in functional group, they have different properties. So this is another example for functional isomerism. This is another example for functional isomerism. For the same carboxylic acids, I'll give one more example here. One more example I am taking. Now I am taking 3 carbons containing carboxylic acid. 3 carbons containing carboxylic acid I am taking. Three carbons means one more example for this one, carboxylic acids and esters. CH3, then CH2, then C double bond O OH. CH3, CH2, C double bond O OH. Here 1, 2, 3. This is the propanoic acid. Propanoic acid. See here I am writing C double bond O and O this side and this side free valencies, free bonds. Now we can divide this. One hydrogen I am writing this side, this hydrogen, and remaining 2 carbons containing alkyl group I am writing this side, CH2, CH3. This is this side ethyl group is there, no? So first you have to write ethyl. Ethyl and this side only one carbon containing alkanoate. So that is methanoate. Methanoate. And one more compound also we can write for ester. How we can write one more compound? Here C double bond O. Oh, this is the functional group, ester functional group. See here these 2 carbons I am dividing. This side I am writing one carbon, this side I am writing one carbon. So here CH3, here also CH3. So this is the alkyl group. So methyl. And here how many carbons are there? This part 2 carbons. So eth and O8. Ethane plus OH means ethanoate, methyl ethanoate, methyl ethanoate. So here one first compound, second compound, third compound. All these three are functional isomers only. 1 and 2 relation because it is acid and this is ester. This is acid, this is ester. For this we can write one more acid also. See, like this I am writing C double bond O OH. C double bond O OH. C double bond O OH. Here I am writing how many carbons? Only 2 carbons, no? So 2 carbons means there is no other way. So only these three. Only these three. Only these three we can write one acetic acid. Okay. Here we can write only these three. Propanoic acid, ethyl methanoate, then methyl ethanoate. Ethyl methanoate. This is methyl ethanoate. So these are the three compounds for which one? What is the molecular formula? I not written here. Molecular formula. Molecular formula you can write 1, 2, 3. C3, then H3 plus 2, 5 plus 1, H6. Then how many options? 2 options. O2. This is the molecular formula. For this molecular formula, we can write 1, 2, 3. You have to observe. After writing these compounds in rough way, then we have to check what is the relation between those two compounds, any two compounds. So checking relation is important here. Okay. Then next example is aldehydes, ketones. Aldehydes, ketones, and aldehyde ketones are functional isomers. But these aldehydes can show functional isomerism with even enols, double bonded compounds. Enol means what? Double bonded compound. Even enols also participated in functional isomerism because we need two different functional groups, but molecular formula should be same. Two different functional groups and molecular formula is same. So one more example, third one here, aldehydes. Aldehydes, ketones. Aldehydes, ketones, and unsaturated alcohols. Unsaturated alcohols, and one more is unsaturated ethers. Remember this. Generally in books they may give aldehydes and ketones only. So unsaturated aldehydes, unsaturated alcohols, and unsaturated ethers. So these many combinations. Aldehydes may show functional isomerism with ketone. Aldehydes may show functional isomerism with unsaturated alcohols, otherwise unsaturated ethers. Ketone also same way. May show functional isomerism with unsaturated alcohols or unsaturated ethers. See here one example for this third functional isomerism. For third means third example. Here I see this question. Acetaldehyde and acetone, or acetaldehyde and acetone. These two are which isomers? Acetaldehyde and acetone are which isomers? Aldehydes and see here acetaldehyde and acetone are which isomers? Acetaldehyde and acetone are chain isomers, or position isomers, or functional isomers, or any other relation. Acetaldehyde, acetone. This is aldehyde, this is ketone. Generally, by seeing this pronunciation, acetaldehyde, acetone, but these are not at all isomers. They are not isomers. For isomers, basic thing is same or identical molecular formula. But these two do not have same molecular formula or identical molecular formula. Acetaldehyde formula, CH3, C double bond OH. That is C2H4O. This is the molecular formula. But acetone is a ketone. First member of ketone it is. So this is the molecular formula of acetone. Only pronunciation is somewhat similar, but molecular formula is not similar. How many carbons? 3 carbons, C3 and H6O. This is the molecular formula. So basic thing is not satisfied here. Here C2 carbon, there C3 carbons. Means 3 carbons are present there, here 2 carbons are present. So that acetaldehyde and acetone, these two do not have any relation related to isomerism, because they do not follow basic rule, which is nothing but same molecular formula. But first, in the options they are given functional isomers, because aldehydes and ketones show functional isomerism, so that you may get confused and you may pick up these are functional isomers, but there is no any relation here related to isomerism. They are not at all isomers. So remember this, they are not isomers. And here this is the important thing. Then acetaldehyde, I am taking CH3 C double bond OH. This is the acetaldehyde. So what is the molecular formula here written? C2H4O. This is the molecular formula. For this molecular formula, ketone is not possible. So acetaldehyde does not show functional isomerism with the ketones. It can exhibit the functional isomerism with the unsaturated alcohols, maybe. Unsaturated alcohol. That unsaturated alcohol, how you can write CH2, here double bond I am writing CH, here writing OH. See here OH group is there, double bond is present between two carbon atoms. If double bond is present in between two carbon atoms, we can say it is alkene. Alkenes are comes under unsaturated compounds. So that this is the unsaturated alcohol, otherwise we can say vinyl alcohol. This is vinyl alcohol. Vinyl group is present. Vinyl group means what? Direct doubly bonded carbon atoms attached to any group. We can say it is vinyl. Vinyl. OH group is attached to double bonded carbon atom, so we can say it is vinyl alcohol. Otherwise, as per UBAC nomenclature, this is the one carbon, this is second carbon, so that it is ethene. Ethene ol, we can say, because on first carbon only ol is there, so we can write it as the ethene ol. Otherwise, enol, this is ene. In the sense, double bond is there. Here OH group is ol, so this is enol. Means two functional groups are there. But here aldehydic functional group is present. This is acetaldehyde, common name, acetaldehyde, and its IUPAC name is two carbons. That is eth or ethane and al, not ol, not ol. Here al, all. This is ethanol. Ethanol is IUPAC name. Ethanol is IUPAC name. So these two are functional isomers, because both are having same number of carbon atoms, same number of hydrogens, then same number of oxygens here, same molecular formula. These two have identical molecular formula and differ in their functional groups. Here aldehydic functional group, here ene and ol both are present. So that acetaldehyde or C2H4O shows functional isomerism with which one? Unsaturated alcohols. Is it possible unsaturated ether? Unsaturated ether is not possible. Unsaturation means there should be minimum two carbon atoms. Between those two carbon atoms, there should be double bond, and one more carbon should be there in ethers. So like this, we can't write CH2 double bond O CH. Like this, it is not possible, because here oxygen cannot show trivalency. Here double bond, two bonds and two hydrogens means four valence is satisfied, but here valence is not satisfied, so that this is not possible. So for this formula we have functional isomer, but that is in all only. If you take three carbons, one more example for this is C3H6O. I am writing C3H6O. For this, first we can write CH3 CH2 C double bond OH. This is the first compound I am writing here. CH3 CH2 CHO. This is the propane. Three carbons are there, so the propane and all. This is propanol. And one more we can write. Second one, CH3 C double bond O CH3. This is ketone. Functional group. It is internal functional group containing compound. Internal means Functional loop should be in the middle. Either side of functional loop there should be alkyl group. Then only we can say it is internal. This is terminal. Aldehydes are always terminal functional group containing compounds like carboxylic acids. For the same, we can write for the same molecular formula. We can write one more. That is CH2 double bond CH. Here C, here OH I am writing. Here H2. See here also 1, 2, 3. 3 carbons. Hydrogens are 2 plus 1, 3 plus 2, 5 plus 1, 6 and 1 oxygen. And we can write one more also then. What is one more? One more unsaturated. CH3, CH, double bond, C here OH, then 1, 2, 3, 1 hydrogen here. Here, fourth one, CH3, 1, 2, 3, 3 carbons, and hydrogens 3 plus 1, 4 plus 1. Here 3, 4, 5, 6, 6 hydrogens and 1 oxygen. And we can write even alcohol also, ether also. How we can write ether? Here I am writing fifth one. CH3, CH2 I am writing here. CH2, double bond, CHO, CH3. See here, 1, 2, 3 carbons and 2 hydrogens. Here 1, 3 plus 3, 6, then 1 oxygen. So this is unsaturated ether. These are unsaturated alcohols, and this is aldehyde, and this is ketone. This aldehyde, that is ketone. So that here these are the different compounds. Generally, we may expect these two. One is aldehyde, other one is ketone. This is propanone. This is the propanone. And here this is 1, 1, 2, 3. We have to give more preference to OH group now, because here two functional groups are there, ol and also ene. As per nomenclature rules, we have to give more preference to OH group, so that it is 1 ol, 2 ene. Means what we can write? Prop 2 ene, 1 ol, 2 ene, 1 ol. And this is same thing, prop 1 ene, 1 ol. This is vinyl group, vinyl methyl ether, otherwise methyl vinyl ether. This is methyl, otherwise methoxyethene we can write. Methoxyethene, methoxyethene we can write. So these are the different compounds with respect to C3H6O. What is the relation between 1 and 2? What is the relation between 1 and 3, 1 and 4? There is 1 and 5, 2 and 5, 2 and 3, 2 and 4. All these are functional isomers. Means these are having same molecular formula and differ in their functional groups. Due to differ in their functional groups, all these have different properties. So that these are the different examples. So 3 examples I have given here. One is alcohols and ethers. Second one is carboxylic acids and esters. Third one is aldehydes, ketones, unsaturated alcohols and unsaturated ethers. In next session, we will discuss about some more examples of functional isomerism only, like nitroalkanes, alkyl nitrides, cyanides and isocyanides, primary, secondary, tertiary amines, and phenols, phenolic ethers. Different examples we have. Different examples along with, if possible, along with those examples, we will discuss about metamerism in next sessions. So that be safe at your home. Thank you.